Well, hello, and welcome to Apologetics 101. I'm here today with Dr. Andrew Snelling. He's been on my channel once before when we were responding to radiometric dating. Um, Dr. Snelling, I know you've been on here before, but do you want to give a brief introduction to yourself? And I know you work for Answers in Genesis, and so kind of just briefly describe that if you want.
Yeah, I have a PhD in geology from the University of Sydney, Australia, and I worked in research and field work for mining companies and collaboration with federal government agencies, research agencies here in Australia. And then I started work in full-time creation ministry, although I continued research with government agencies. And so, yes, I've been involved in research and in the creation science area now for over 40 years.
As additional note, though, you also was a major part of the rate project that happened back in the
Yes,
late '90s and early 2000s.
yes, I
That's
should
relevant to
mention,
our discussion today. Go ahead.
yeah, I should mention that my PhD was on a uranium deposit in Australia, and some of the work I was doing was with the Australian Nuclear Energy Agency, uh, Nuclear Science and Technology Agency. So a lot of my research was related to radioisotopes. And as you said, I was involved in the RATE project, Radioisotopes and Age of the Earth project from 1997 to 2005, and was a major contributor and editor of the two volumes that research project produced. And I'll be talking about some of those research results today.
These two books right here,
Correct. Yes.
volumes one and two. Awesome. And you have a presentation for us today as well, and we'll
Yes.
be discussing that following the end of that presentation. Um, so, do you want to just go ahead and jump in and
Absolutely.
begin? All right.
The age of the Earth question. Most people think that the geologists have measured the age of the Earth with radioactive dating of Earth rocks. And, therefore they've proven that the Earth is 4.57 billion years old. But what most people don't realise, the Earth's claimed age was never derived from Earth rocks. It was actually derived from the radioactive dating of a group of meteorites. And here is the isochron age for the Earth, otherwise known as the geochron, 1956, Claire Patterson at Caltech. He took a group of iron meteorites, including the Canyon Diablo meteorite there in northern Arizona. And he plotted, because he could plot a modern ocean sediment on that isochron, that was declared as the age of the Earth. Now, what most people don't realize then, that this assumes that the meteorites represent the Earth when it was formed. In other words, it's assuming how the Earth and the solar system was supposedly formed from the solar nebula. And biblically, it's wrong, because the Bible tells us that the Earth was created on day one. The sun, moon, and stars and the rest of the solar system weren't created until day four. So the Earth didn't come out of the sun as a hot molten blob, and yet that's the assumption on which this age of the Earth determination was made, the meteorites being leftover materials from the solar nebula. And so that age is based on an assumed evolutionary history, and then it's used to prove that evolutionary history, which of course is circular reasoning. And ultimately, it also assumes that radioactive dating methods work absolutely, which of course is the subject of our discussion this morning. So let's look into these radioactive dating methods. Some atoms of some elements, for example, carbon 14, which we'll come back to later, it's a short age method. We're first of all interested in uranium 238, which is a long age dating method. But these atoms, their nuclei, have too many particles, and so they're unstable. And what happens is the unstable nuclei decay by ejecting some of the subatomic particles from the nuclei so as to reduce the size of the nuclei to make the atom more stable. And so this process of ejecting nuclear particles from nucleus, is called radioactive decay. The decaying atoms are often known as radioactive isotopes or simply radioisotopes. And so a radioactive atom or radioisotope of one element decays to stable atoms of a different element. And so we call the decaying radioisotopes the parent atoms and the stable resulting atoms the daughter atoms. Minerals, rocks, and fossils often contain some of these radioactive parent atoms, radioisotopes, and the daughter atoms. And so here are some of the examples. Carbon-14 decays to nitrogen-14, uranium-238 to lead-206, uranium-235 to lead-207, potassium-40 to argon-40, strontium-87 to rubidium-87 to strontium-87. One you may not have heard of, samarium 147 decays to neodymium-143. And those are rare earth elements, samarium and neodymium. Neodymium is a critical element because it's used in strong magnets in those wind farms to generate electricity. So they're the major ones we're going to talk about today. So how does these methods work? Well, a rock is chemically tested for these parent and daughter atoms. And if the radioactive decay rate has remained constant at the measured rate today, then it can be calculated how long it has taken for the measured amount of daughter atoms to have accumulated. And that's called the rock's age. Let's use an analogy here, not the best analogy, but it will serve our purposes. An hourglass clock that many people are familiar with. We have all these sand grains which start in the top glass bowl. They fall to the bottom. So the analogy we're using, all the sand grains at the top are the parent atoms. Radioactive decay is the falling process, and the daughter atoms accumulate at the bottom sand grains. And that's the analogy. And so if we start with all the sand grains in the top bowl, it takes 1 hour in an hourglass for all those red sand grains at the top to fall to the bottom bowl and become green sand grains. So we test our rock for red and green atoms. And so it's like this, you and I can measure by looking at the red sand grains and the green sand grains at the bottom, and we can work out, so for example, if half the red grains are at the top and half the green grains are at the bottom, it's an hourglass, how long it's been ticking. We know the rate of falling, therefore it's been ticking for half an hour by actually measuring the parent sand grains and the daughter sand grains. So if the rate of falling has remained constant, it can be calculated how long it has taken the measured amount of green atoms to accumulate from the red atoms at the top, the parent atoms. So we know how long the hourglass has been operating, and so that's determined as the rock's age. It really isn't hard conceptually to consider this process. But the use of the hourglass to tell the time requires 3 crucial assumptions. And if they're crucial for the hourglass, they're also crucial for the radioactive dating methods, even more crucial. Let's run through these assumptions, okay? 3 crucial assumptions. First, the amounts of parent and daughter atoms at the beginning when the rock formed, that is, the initial conditions must be known. Now, when we were using our hourglass, say in the kitchen, we turned the hourglass up so that all the sand grains were at the top and were red sand grains. We put a cake in the oven, and then we started the clock ticking. We went off to do some laundry or cut the grass, and we come back later and we look at our hourglass clock. We want to know how long it's been ticking. We do the measurement, Well, we're assuming that all the sand grains were at the top at the beginning. Well, we know that because we were there. But that's assuming there were no sand grains, green sand grains at the bottom to the beginning. We were there, and that requires an observer. So were there observers there when the rocks formed supposedly millions of years ago? No. So how do we know there were no green atoms with the red atoms to begin with? We don't know for sure. We just have to make assumptions. So, for example, in the potassium argon method, we assume that there was no argon at the beginning. There was no inheritance, no argon inherited when the rock formed. But what if there was? Well, then that's a problem for our clock. Assumption number 2, all the daughter atoms measured today must only have been derived by in situ radioactive decay of the parent atoms. In other words, it has to be a closed system. So, that means that while you're out of the room, you didn't know your mischievous 10-year-old son came in and lifted up the lid and put more red sand grains at the top, so that when you came in and did your measurement, you didn't realise the system had been contaminated, and so your clock had been going for longer than you realised. And so the system was contaminated. All the green sand grains must have only been derived from falling of the red atoms. That is, there has to be no contamination. And that requires an observer. You weren't there to watch your hourglass clock because you went out to cut the grass. Were the geologists there for millions of years watching these rock layers after they formed to make sure there was no contamination? No. And we can show that there's been contamination in the present, which we'll come back to in a moment. And then the third assumption is that radioactive decay, that is the falling rate of the sand grains, must have been constant at today's measured rate. That means the red atoms had to fall constantly to form the green atoms at a constant rate that we measure today. But when you're out of the room, you didn't realise that when your son lifted up the lid, he also put a few drops of water in, and that clogged up the sand grains so they didn't fall as quickly. He slowed down the falling rate by clogging up the orifice, and so they didn't fall as quickly, and so he's ruined your clock. You weren't there to observe. Were the geologists there for millions of years to see that the decay rates have been constant? No. So you can see that these 3 assumptions, all the order atoms derived from the parent atoms, requires no initial inheritance. Assumption 2, no other processes affected the parent-daughter relationship, no contamination. And assumption number 3, constant decay rates. That means the rates haven't changed through geologic time. None of these assumptions are provable. Why? Because the past cannot be observed and measured. We only have the present to observe. We only have the present to measure what's going on. We weren't there in the past. So these assumptions are not provable, and they're not even reasonable. Why? Because even today, with today's observations, we can show that all these 3 assumptions have been repeatedly falsified. And if they've been falsified in the present, that means we can't trust them in the past, which is a real problem for these dating methods being reliable. The daughter atoms are known to have been inherited when the rocks formed. We're going to work through this. We're going to use examples. And just because inheritance hasn't been detected doesn't mean it's there. We assume we've got the right date, but that date might be because of inheritance that we haven't been able to detect. Assumption number 1, no inheritance, has often been violated. Subsequent contamination is common. Even if it isn't detected, doesn't mean that contamination isn't present, because it could be systematic. And I'm going to show you some examples. So assumption number 2, contamination is often violated. I mean, the rocks have been sitting out there for millions of years, supposedly, with rain falling on them, groundwater going through them. Groundwater leaches uranium, it transports it. How do we know there hasn't been contamination? And what we're going to see today is that several lines of evidence have demonstrated conclusively that decay rates were grossly accelerated during a recent past catastrophic event. So if decay rates have changed in the past, then assumption number 3, no changed rates, has been violated. Now, I want to emphasize here that the quality of the chemical analysis is not disputed. We can take a sample, divide it into subsamples, and set those subsamples to several laboratories, and they will each come back, I guarantee, with similar results. Why? Because these are well-constructed laboratories. Millions of dollars have been spent on pure chemistry labs for extraction of the isotopes, and the quality of the chemical analysis is superb. But we have to remember that the chemical analyses are interpreted as ages. The chemical analyses are good, but then we have to interpret what those analyses mean based on our assumptions, these unprovable, repeatedly falsified assumptions. And that's where the problems lie for the reliability of these dating methods. So let's start looking at some examples. Mount St Helens erupted in May 1980. We've just passed the 46th anniversary, May 18, 1980. And subsequently, a new lava dome formed inside the blasted out crater. And my colleague Steve Austin went up there, climbed up into the crater, and the activity was being monitored by the USGS. So they knew the dates when lavas had flowed to keep forming this new lava dome. And there was a dacite lava flow in 1986 that Dr. Austin sampled, sent it to the laboratory, and submitted it for potassium argon dating. And these are the results that were attained. A whole rock age of 0.35 million years, various mineral ages because he extracted minerals as well from the whole rock, and a pyroxene concentrate gave an age of 2.8 million years for a rock that at the time it was being dated, it formed in 1986, it was dated 10 years later, it gave ages up to 2.8 million years. The conclusion was that these old ages were due to inherited excess argon. And this was well known from the literature. So Steve Austin has been accused of using a wrong method to date these rocks. No, secular scientists had also dated recent historic lava flows by the same method and got old ages. The Hulupai basalt in the Big Island of Hawaii, lava flows right by the airport there in Kona, where they've now got a golf course. Those were sampled. The lavas were seen to erupt 1800 1801, gave ages of potassium argon ages of 1.4 to 1.6 million years. And there's other examples there from Mount Etna, from Larsen Peak in California, and Sunset Crater in Arizona, which was known to erupt in AD 1064 and 65. And so you can see these methods aren't reliable because of inherited argon. Pillow basalts erupted in Hawaii, that is, they erupted underwater. The pillows congealed very rapidly at the rim, and it trapped excess argon, giving ages up to 43 million years. And samples taken from within these pillows gave younger and younger ages because it had less and less argon, and there'd been time for the argon to bleed out. And here's further samples. Some of those I've shown you before from various papers. Seen there on the right of the table, there's the Hulupai basalt again, AD 1800, 1801, ages up to 22.8 million years. So Others have dated these rocks, so it's false to accuse Steve Austin of wrongly dating using the potassium argon method to date the Mount St Helens eruption in 1986. Diamonds have also been dated using potassium argon. In this case, 10 diamonds from the Democratic Republic of Congo yielded a potassium argon isochron age of 6 billion years. Well, they knew that those were wrong, that date was wrong, because how could the diamonds be older than the age of the Earth itself, 4.57 billion years? So obviously these diamonds had inherited extra argon. 2 volcanic centres, 100 miles apart in the African Rift Valley, whose lavas were known to be less than 1 million years old, yielded a rubidium strontium age of 773 million years. I mean, these are lavas 100 miles apart. And 14 different recent ocean island basalts yielded a rubidium strontium age of 2 billion years. Now, these are results from the literature. These are from the open, secular, conventional, peer-reviewed science literature. It's not me making these up. They're well documented in the textbooks on these dating methods that are used to teach them in universities around the world. And it's well known that recently erupted lavas on ocean islands around the world, and you can see the names of them there. They're well known: Easter Island, Reunion Island, the Hawaiian Islands, Ross Islands, Canary Islands, the Azores. They regularly give lead ages of between 1 and 2 billion years. And this is in the literature has been called the lead isotopes paradox. It's been known for over 50 years. So let me give you another example. In the Western Grand Canyon, and this is very instructive. In the Western Grand Canyon, there are lava flows that are so recent, the lavas flowed down the walls of the Grand Canyon and accumulated, blocking the Colorado River. They're called the Uinkaret Plateau basalts. Now, deep in the Grand Canyon, in the Eastern Grand Canyon, are ancient lava flows, the Cardenas basalts. So here are these recent lava flows. Here's Vulcan's Throne, one of these craters. You can see the flows, remnants of the flows on the walls of the canyon. You can see the Colorado River down there. Just there in that area, the Colorado river was blocked, dammed up until the waters burst through. Here's these ancient lava flows in the Eastern Grand Canyon, the Cardenas basalt. Now, what sort of results did these give? Well, we've got rubidium strontium ages, isochron ages of 1,143 million years for the Uinkaret Plateau basalts. When I say we, this is from the literature. And the rubidium strontium isochron age for the Cardenas basalt is virtually the same, 1,111 million years. Within the error margins, those are identical rubidium strontium ages. How is it that the youngest lava flows at the top of the Grand Canyon yield the same old rubidium strontium age as the oldest lava flows down in the bottom layers of the Grand Canyon? The answer is that all these lavas came from the same upper mantle source underneath the Grand Canyon area. Basalts come from the upper mantle. Melting occurred in the upper mantle, not in the crust, which is granitic, but from the upper mantle. So if they came from the same source, these rubidium strontium ages reflect the chemistry of the source. Therefore, they cannot be real ages. They reflect the rubidium strontium chemistry of the source. So, just from these few examples, documented in the open scientific literature, we can see that assumption number one is violated by inheritance of daughter isotopes. mantle chemistry. Okay, what about assumption number 2? No other processes affected the parent-daughter relationship. Have these rocks been closed from contamination? Let's go to Mount Narahoi in the central North Island of New Zealand. And here's Mount Narahoi. You might recognise that. That was Mount Doom in the Lord of the Rings movies where those were filmed. Here's Mount Narahoi up close and personal. I went in there and collected samples. You can see streaks on the slopes of the volcano. You can see that some are not as well grassed as others, and that's how you can tell the different ages. These have been carefully mapped from observed eruptions. And here's a map of some of these lava flows and the dates of the lava. Notice the day, the month, and the year are known. And I sampled those and I set them for potassium argon dating, and we got ages we're up to 3.5 million years, indicating excess argon was inherited from the mantle source. And that's because the volcanic gases contain excess argon. And when the rock congeals, it traps some of those volcanic gases in them, and excess argon is inherited. The rubidium strontium age, isochron age for these lavas was 133 million years. And the daughter atoms, strontium, neodymium, and lead isotopes, indicate we can use those as a marker that 5 to 10% crustal contamination had been occurred. You see, it started as a basalt in the upper mantle. Then as it came up through conduits, it inherited bits of the wall rock, which was granitic in composition, and that mixed in gave a 5%, 10% contamination, and that turned the basalt into an andesite. And so there was contamination as the rock came up and erupted. Let me look at some other examples in the literature. A granitic rock in South Africa yielded a lead, and samarium isochron age of 2,915 million years, but a rubidium isochron was obtained from minerals within the rock, and that gave an isochron age of only 2,023 million years. And one of the feldspar albite, that's a plagioclase grain in the rock, yielded rubidium strontium ages of 5,852 million years at its outer edge, which is larger than the age of the Earth, and 3,067 million years inside its core. So, these variable ages indicate contamination has occurred by movement of these isotopes within the mineral grains within the rocks. Here's another example from the literature. Out in Colorado, granite intrudes into Precambrian, a recent granite, supposedly 54 million years old, intrudes into Precambrian schists and fibrilites that are supposedly 1,375 million years old. And samples were taken from the host rocks, the Precambrian schists and fibrilites, at various distances from the edge of the granite. And when plotted up, what did we find? As we got closer to the granite, the ages decreased and got closer to the granite's age. We're talking about kilometres away. The rubidium, strontium, and potassium argon ages got younger and younger as you came in closer and closer. The same with the lead and uranium lead ages, although the distance here was only feet, not meters, thousands of meters. But yet there was this contamination. Why? There was contamination from the heat and the fluids, the hot fluids from the granite and the heat permeated out into the host rocks and caused this contamination and depletion. Here's some other examples. Granites often contain zircon grains. Now, these zircon grains crystallize as the granites crystallize. And normally the zircon should give you the same age as the granite because they formed at the same time as the granite. But that's not always the case. And when it's not the case, it's assumed the zircon grains were inherited. And the only reason they're assumed to be inherited is because the ages of the zircons don't match the granites themselves, which of course is only an assumption. It's not provable. So here's three examples. A Himalayan granite, supposedly 21 million years old, dated by other methods, had zircon grains in it dated up to 1753 million years old. A granite, a granite in southeastern Australia, supposedly 476 million years old, dated by rubidium strontium, had zircon grains in it up to 3.5 billion years, 3,300 million years old. And a granite in New Zealand, supposedly 370 million years old by other methods, had zircon grains dated in up to 1,638 million years old. Now, if you think that's bad, what about this example from the Himalayas? A granite there, supposedly 20 million years old, had within it zircon grains that gave uranium-lead ages up to 1,483 million years old, but it also had monazite grains, which is another uranium. It's a calcium phosphate mineral that also contains uranium in it. It gave uranium-lead ages of minus 97 million years. In other words, minus 97 million years means the monazite grains hadn't yet formed, which is totally ridiculous. That means there had to have been contamination. Here's another example from the literature. Biotite grains in a metamorphic rock that was side by side were dated using a laser pointer to zap these points. You can see them numbered here. You can see the edge there between two grains. Okay. And look at 2, 3, 4, 5, 6, right through to 12. Okay. When we plot these on a graph, look what we find. There's the edge of the grain between biotite grain A and B. The ages decrease as we go in from the edge. Why would they decrease? That's because at the edge is where argon could migrate and accumulate and seep into the grains, giving wrong apparent ages for these grains. Here's another example. These are crystals of bedyllite, which is similar to zircon, but slightly different. It's a zirconium oxide mineral. And this crystal was mounted and it was focused beam. Beam was focused on different crystal faces that were rotated for different angles for different crystal faces. Okay. And when plotted like this, you can see the way the grains were rotated. The ages varied by up to 400 million years on different faces at different angles on the same grains. Wow. And this is in the open scientific literature. So we can see assumption number 2 is violated by contamination, which is routinely found. Now, it has been insisted that assumption number 3, constant decay rates, is universally true because the resultant millions of years ages are needed for evolution to be possible. But why should the decay rates have been always constant at today's measured rates? After all, if we can demonstrate that other geological processes have been catastrophic in the past, why cannot radioactive decay rates have been catastrophic in the past and speed it up? So here again are the four major methods: potassium, argon, rubidium, strontium, uranium, lead, samarium, neodymium. Now, geologists usually only use one or two of these methods on the same rock samples. Why? Because they assume that all methods should ideally use the same age for the same rocks, which in theory and practice they should. After all, it's like having a series of different hourglass clocks, four different clocks with different sand grains that are different sizes in each clock, larger and smaller grains in the top. They should all fall at the same rate. They all should fall and therefore should ideally give the same age with just four different clocks. And that's what theory and practice assumes. But what would happen if we used all four methods? We saw an example previously of a granite from South Africa. Rubidium, strontium, and samarium, neodymium isochron ages agreed, but when we looked at the minerals, we got different ages. So what if we use the isochron method, which is the superior method when you take 4 or 5 samples and plot them, the chemical analyses? The reason we do that is because we can often tell whether there is contamination and inheritance as a result of the isochron. If it doesn't go through the 0, 0 of the plot, we know there's been inheritance, and points that don't fall on the line indicate contamination. And what if we used all four methods with the isochron technique? So that's what we did in the RATE project, the radioisotopes and age of the Earth. We sampled from top to bottom this diabase sill in the Grand Canyon. That's where basaltic magma was squeezed like toothpaste between the layers and cooled between the layers, a coarser rock known as the diabase. And here it is on the geological diagram of the Grand Canyon, right down there near the bottom. And these are the results that we got. Which is the correct age? Potassium argon, 841.5 million years. Rubidium, strontium, these are isochron ages, 1,060 million years. Lead isochron, 1,250 million years. Samarium, neodymium, 1,379 million years. Or option A, none of the above. I mean, these are all different ages. How do we know which is the correct age when no one was there to observe when the rock was actually formed? Problem. Notice the potassium argon gave the youngest age. Rubidium, strontium was the next youngest, and it was younger than the lead, and the samarium ages. I make that comment because we're going to see a pattern emerge when we look at other examples here. So let's look at the Cardenas basalts, those ancient lava flows in the eastern Grand Canyon. Here they are. We can see them from the rim and observe them from an overlook from the eastern Grand Canyon. You can see these lava flows are sandwiched between layers deep in the canyon. These are Precambrian layers. Here they are up close and personal. These were sampled, and these are the results. Potassium argon gave an isochron age of 516 million years. Rubidium, strontium gave an age of 1,111 million years. That's over twice the potassium argon age. And the samarium method gave an age of 1,588 million years. That's 3 times. That's over 3 times the potassium argon age. I mean, are any of these methods reliable? No one was there to see. I mean, and the secularists know, the conventional people know that the potassium argon age can't be right because that's younger than some of the overlying rocks, their supposed age. And look at the wide discrepancy in these ages. Notice again the potassium argon is the youngest, rubidium, strontium is the next youngest, and it's younger than the samarium, neodymium. There's a pattern emerging here. And we know that even the 1,560 16 million year isochron age is got excess argon on, because notice the isochron doesn't go through the 0 point. That means there's excess argon was inherited to begin with. Whoa, this is a real problem. Now, let's look at the salts that were metamorphosed. And when they were metamorphosed, of course, that would have reset the radioactive clocks. Well, that's what the theory says. Amphibolites are metamorphosed basalts, and they become schists when they're metamorphosed. Here they are right down deep in the basement, the lowest part of the Grand Canyon. What results did we get? A rubidium-strontium age of 1,240 million years, a lead-lead age of 1,883 million years, a samarium age of 1,655 million years. Which is the correct one? How do we know without an observer? Notice again the rubidium-strontium was younger than the lead-lead and samarium. Now let's look at the oldest rock in the Grand Canyon. This is the Earl's Chasm granodiorite, regarded to be the oldest rock in the Grand Canyon. And what results did we obtain? There it is, right at the bottom. It intrudes into the metamorphic rocks. Okay. Rubidium-strontium, 1,512 million years. Lead-lead, 933 million years. Samarium, 1,664 million years. These three methods don't agree. Which is the correct age? We don't know. We don't have an observer that was there. Notice, again, the rubidium-strontium is the youngest. So multiple ages, radioisotope ages, using the isochron methods on 4 units are different. They always disagree. Yet each of these rock units represent a unique, once-only geological event: the formation of the sill, the eruption of the lavas, the metamorphism of the lavas, the crystallization of the granites. These are one-time unique events that should be datable. That's when the clocks were started. So if these radioactive clocks were accurate, always ticking at the same rates as measured today, these 4 different hourglass clocks with different sand grains at the top, starting at the same time, ticking through the same real historic period between the formation of the lavas, the granite, etc., and today, they should all give the same age. But they don't. They give different ages. That means the clocks must have been ticking at different, faster rates than measured today. Why do I say faster ages, faster decay rates? Well, look at the Cardenas basalt. It means that while the potassium argon clock was ticking through 516 million years, the rubidium strontium clock must have been ticking faster through 1111 million years, which means the potassium argon clock must have been faster too. And the samarium clock was ticking even faster still through 1588 million years. So that means the different ages can be explained by accelerated decay rates, faster decay rates in the past, faster than what we measure today. And the systematic pattern indicates there has to be a pattern to this acceleration, and it's related to the different atomic weights. The heavier the atom, the faster the more there was acceleration, which means, for example, uranium has a larger nucleus than a samarium atom. Therefore, decay rate was accelerated greater than a rubidium, which is very much smaller, and potassium is smaller still. And that explains why the potassium gives you the youngest age, because it was accelerated the least. And rubidium was accelerated a little bit more than potassium, but less than uranium. And radiocarbon, it was hardly accelerated at all, because its half-life is only 5,730 years compared to over 1 billion years for potassium. So, and we'll come to that again later. So this means that constant decay rate assumption number 3 is also violated by accelerated decay rates. So what happens if the evolutionary community simply ignores these problems with the assumptions? That's because they're convinced that the isochron technique supposedly eliminates these assumptions because it can show the initial conditions where there was contamination, as we illustrated with the Cardenas basalt, and showed that there was still excess argon in that isochron, potassium argon isochron. And the isochron shows where there was contamination if samples do not plot on the isochron line. But is that assumption that the isochron is always an age correct? They say that these methods work because it gives them the ages of the right order. After all those ages in the Grand Canyon were still Precambrian. Well, yeah, because the acceleration occurred for so long that it made the ages vast. However, isochrons can also indicate inheritance, as we have seen, okay? Inherited from the fluids and heat from a granite. And not all isochrons are real ages, as we can show. So do isochrons always represent ages? Isochrons are straight lines based on chemical analyses of four or more samples or minerals of the same rock unit. They are claimed to represent the age of the rock unit, but do all such straight lines always represent ages? Let me give you an example. Let's go to Northern Australia, and let's go to the Koongarra uranium deposit east of Darwin in the Kakadu National Park. This is actually the uranium deposit on which I did my PhD research, and I worked for the mining company subsequently, working towards development of that uranium deposit. It has never been developed into a mine because it's in a national park. That's another story. But I helped do research with government agencies on that uranium deposit. Here's a famous landmark near the deposit, which shows you why it's in a national park. Beautiful country, sandstone cliffs, beautiful billabongs, which are oxbow lakes. Here's the uranium deposit from the air, the drilling grid. And I often stayed in that exploration camp doing research, etc. Here's an example of the uranium. That's a drill core sample. The black, of course, is uraninite. Uraninite has been altered to sclerosite, kaiserlite. These are alteration minerals, but this is typical high-grade uranium ore. Now, a colleague and I took soil samples from above the uranium deposit, and we took soil samples for up to 20 miles away from that uranium deposit. Some of the samples were over the other side of a mountain, that Mount Brockman, okay? And then we did lead-lead isochron analyses, isotope analyses, and plotted them on an isochron diagram. And guess what? This is the isochron we obtained. It had a perfect fit. The soil samples over the deposit plotted on the line, but also the soil samples up to 20 miles away on the same isochron that gave an age of 1,445 million years for those soil samples up to 20 miles away. How could they be the same age, give the same age as the soil samples above the ore deposit? The soil samples that above the deposit obtained their lead isotopes from the water, groundwater, seeping down into the to the ore. In fact, on top of in the soil, in the weathered horizon, there was also a fan of alteration where the uranium had been altered and it was moving the uranium down flow. And so we know all that. I did another study on that, which is in the literature. So here we can see this is a mixing line, not an isochron line. We also know from granites in southeastern Australia that the strontium and neodymium isotopes from different granites show there's been mixing in these granites of a mantle component and a crustal component to these granites. And that means that the rubidium, strontium, and samarium neodymium ages, these granite isochron ages, are due to contamination or mixing of these components. So isochrons, even with an excellent fit of the data, are known instead to be mixing lines, and therefore they cannot represent the ages of soils or rocks. So all such straight lines do not always represent real ages. Is there any other evidence of past accelerated radioactive decay rates? Yes. There are 3 other lines of evidence that I want to focus on today that are consistent with past accelerated radioactive decay rates. These are helium diffusion, polonium radiohalos, and also radiocarbon. I said we'd get to radiocarbon, and we will, last of all. So let's look at helium. Helium is a byproduct of uranium decay to lead. Every uranium atom that decays down that decay chain, it goes through 8 alpha particle steps down to lead. Those alpha particles, when they spit out, combine with electrons, stray electrons, to produce helium atoms. And so we can also get uranium-helium ages as well as uranium-lead ages in zircons. Now, there was deep drilling done near Los Alamos, New Mexico. They were exploring for how hot a granite got at depth, so potentially using that granite for geothermal energy. And zircon grains were recovered, extracted from that granite. And these zircons contain uranium, lead, and helium. And so the uranium-lead radioisotope age could be measured. And a good isochron age of 1.5 billion years was obtained. That's 1,500 million years. The helium retained in these zircon grains were measured at different depths down the drill hole. And you can see this on this table. Notice that the temperature rose with depth. Look how hot the granite got nearly 4 kilometers down. 277 degrees C is over twice the boiling point of water, which is at 100 degrees C. And we passed that temperature at a mere 960 meters down. And of course, the further down we went, less helium was retained because the heat excites the helium atoms and helps them to diffuse out. See, helium is a lightweight, fast-moving, slippery atom. It's a noble gas. It doesn't chemically connect with other elements. And so the hotter the crystals, the more energetic the helium atoms become, the faster they leak, which means that's why the deeper samples had less helium in it, because at the warmer temperature, the helium had diffused out. So the helium leakage rates can be plotted against their temperature. The hotter the zircons, the faster the helium leakage rate is. But no one had really measured this leakage rate before we measured it, got it measured, we made predictions. The leakage rate equals the helium loss over time. So let's assume there was only 6,000 years since the granite formed, the creation model, and calculate the leakage rate based on the helium lost, because we've measured it down the drill hole. And let's look at a leakage rate calculated from the helium lost over 1.5 billion years, the long age. Okay, and we plotted those, and what did we find? There was a factor of 100,000 difference between where the helium leakage rate should be for only 6,000 years of leakage versus where the helium diffusion rate should be for 1.5 billion years of leakage. And we actually published this prediction. We stuck our neck out before we even did got the laboratory to test these zircon grains. We actually published what we would predict. And guess what? The helium rates were measured in a world-class laboratory by a scientist who had done these helium diffusion measurements on other zircons elsewhere. And guess what? The experimental data fitted exactly to and overlap with the 6,000 years prediction. The data came nowhere near the 1.5 billion years prediction. We'd falsified the 1.5 billion years age for those zircon grains. Why? Because leakage rates, leakage is by a well-known physical law. And when we calculate the leakage rates, using that leakage rate to calculate the ages of these zircon grains, look at the ages we obtain. We have a helium diffusion age of under 6,000 years for these zircons. So here we have two ages. We have a helium diffusion age of only 6,000 years based on a well-known, well-studied physical law, Fick's law for helium leakage, and yet the nuclear decay age gave a 1.5 billion years. That means if these two clocks had to be reconciled, the nuclear decay age has to be reconciled to the helium diffusion age. That means that the decay rates had to be grossly accelerated by 6 orders of magnitude, by 100,000 times. To reconcile these ages, 6 orders of magnitude. Woo! So that's the helium diffusion. Let's move on to the second lot of evidence. Let's go to a granite east of San Diego in California. We look at that granite and we can see black, flaky grains in it. That's the mineral biotite. Within the biotite are zircon crystals, tiny crystals. The zircon crystals contain radioactive uranium atoms that spit out alpha particles, which are 2 neutrons and 2 protons. Okay. And there's 8 decay steps. We saw that, we talked about that earlier with regard to the helium. Okay. 8 alpha particle decay steps to transform uranium into a stable lead atom. And each of these decay steps have different energies, with alpha particles of different energies. Okay. Now, where the zircon crystals are large, the alpha particles stay within the zircon grain. They cannot escape. They haven't got enough energy to get outside the helium crystal. And so they combine with stray electrons to produce helium atoms that stay within the zircon crystals. And that's where earlier we were talking about helium diffusion. But where the zircon crystals are tiny, only 1 micron in size, the alpha particles ejected out of the zircon grains cannot escape, and they damage, they accumulate within the surrounding biotite flakes. And the different alpha particles go different distances because they've got different energies from the different decay steps. And they damage the crystal and cause discoloration. It's like shooting a bullet into a drywall. You put a hole in the plaster. Well, the gyprock, the plasterboard. Well, it's the same with the alpha particles. They damage the crystals. The discolored area is called a halo because it's going all these particles are going all different angles, but we're looking at it in a 2D slice. Forms a halo around the central zircon crystal you can see in this photograph on the right, and you can see the discoloring around it. That halo is called a radioactive halo or radiohalo abbreviation. So if we get 8 decay steps, we get eight different rings, because the most damage is caused at the end of the particle shooting out from the central zircon crystal. And different energies, you can see the different energies for the different steps. So we can tell each of these rings, for example, the largest ring is the most energetic, and that's the decay of polonium PO 214, has an energy of 7.69 million electron volts. And so we can tell that ring, outer ring, is due to that polonium decay. So this has been established experimentally, as well as all these observations. So here we can see one of these fully formed uranium radiohalos with 8 rings. It's being demonstrated to form a fully formed dark uranium radiohalo requires 500 million to 1 billion alpha particles. And that equates to 100 million years worth of uranium decay at the present known uranium decay rate. Okay, that's a lot of decay, a lot of the alpha particles. So as I said, that many alpha particles is equivalent to 100 million years worth of uranium decay at today's measured decay rate. So granites and schists all around the world contain dark uranium radiohalos. All these granites and schists thus contain observable physical evidence of abundant nuclear decay of at least 100 million years worth at today's decay rate. However, in many granites and schists, biotite flakes are also found with radioactive radiohalos of containing only one small ring alongside the dark uranium radiohalos. See in this example here, on the right there, we see a radiohalo with one small ring. Notice the very dark uranium radiohalo on the left is all dark and blurred. That's because it's had more than 100 million years worth. It's had so much decay, uranium decay, that it's blurred. It's everything, all the rings are blurred and merged, etc. In some granites, we find radiohalos with 2 rings. In this case, the outer ring is very faint compared to the inner ring, but there's 2 rings there, and they're less in size than the very dark uranium radiohalo. And then in some granites and schists, we find biotites with 3 rings, radiohalos with 3 rings, okay, that are different from the nearby uranium radiohalos. So these 3 radiohalos and their rings correspond to the last 3 decay steps, parented by polonium 218, polonium-214 and polonium-210. So, for example, a radiohalo parented by polonium-218 will have 3 rings because the polonium-218 decays to polonium-214, decays to polonium-210, 3 steps, 3 rings. If the radiohalo is parented by polonium-214, 2 steps, decay of polonium-214, then decay of polonium-210. And then if it's only the radiohalo is only parented by polonium-210, then there's only 1 decay set, polonium-210. And so we find some granites have polonium radiohalos, biotite flakes in these granites have schists, in the schists and granites have polonium radiohalos that are polonium-212, polonium-214, and even polonium-218 in the same biotite flakes as the uranium-238 radiohalos. So big deal. Why is this a big deal? Because these polonium radiohalos have been described in a very famous US court case as a very tiny mystery. Why are they a very tiny mystery? It's because these polonium isotopes are very unstable. They only have fleeting existence. They have very fast decay rates, as measured today. Polonium-218, 3.1 minutes. Polonium-214, 164 microseconds. You blink and they're gone. Polonium-210, 138 days. So these polonium radiohalos had to form extremely rapidly before all the polonium decayed away. Now, Robert Gentry, back in the 1980s, claimed there was no natural process capable of forming the polonium radiohalos because he claimed a concentration of 50% polonium is needed in the radio center, that is, within the central nucleation point of the polonium within the biotite crystal, had to be there all at once. So, for example, a polonium-214 radiohalo to form had to have 50% 214 concentration transported to that radio center within a millisecond or two. Remember, it decays at 164 microseconds, I should say. Blink and it's gone. So he said these radiohalos had to be created, therefore the granites had to be created. But wait a minute. Why would God create polonium radiohalos in granites and allow the uranium radiohalos to subsequently form alongside them over millions of years in the same biotite flakes? Furthermore, these biotite flakes contain both polonium and uranium radiohalos. They're found in granites and schists all around the world that can be shown to have formed during the biblical global flood cataclysm. So, for example, I can take you to southeastern Australia, where we find a granite that intrudes into metamorphic rocks. We can take you from the metamorphic rocks, where the metamorphism is at a low temperature, and we can walk closer to the granite. The metamorphic rocks show higher and higher temperatures, so we can show where the granite formed as a result of melting of those rocks. And I can show you that their biotite flakes in the schists and granites all contain these radiohalos, polonium and uranium radiohalos. And the metamorphic rock formed as a result of metamorphism and the granite from melting of fossil-bearing sedimentary rocks. So they had to form during the flood, which means there has to be a new model for the formation of these radiohalos. Now, polonium is a rare element. Where did it come from? Very rare element, but it has a chemical behavior similar to lead. It loves sulfur. the only nearby source of polonium is uranium in the zircons. The zircons, when they decay, generate polonium. And the radiohalos are in the same biotite flakes. So if the polonium came from the uranium from the zircon, it means that the uranium-polonium radiohalos formed at the same time in the biotite flakes. It means there had to be a way of transporting rapidly polonium from the zircons, where the uranium was forming, to new locations in the biotite flakes surrounding them. Uranium had to deliver enough polonium to generate 500 million to a billion alpha particles to form each dark polonium radiohalo before the polonium decays. That means the process had to be rapid. That means the granite had to be formed rapidly. Why? Because as the granite forms, it puts out water, hot water, that is capable of transporting the polonium, hydrothermal fluids, and that permeated between the biotite flakes. The biotites as a sheet mineral with fractures between the sheets called cleavages. The water would flow between those sheets to transport the polonium. At least 100 million's worth at today's decay rate had to have been transported within a few days. Uranium had to decay so rapidly that within a few days it had generated at least 100 million years worth for transport, which meant the decay rate had to be accelerated. You see why this is evidence for accelerated decay rates? It's been observed and experimentally determined, by the way, that radiohalos can only form below 150 degrees Celsius. Otherwise, the alpha particles, the tracks are annealed. They're obliterated. Now, 150 degrees might sound hot, but it's cool because the granite starts crystallizing at over 600 degrees. And under 400 degrees, it starts, 200 degrees, 275 degrees, it starts expelling hot water. So once it expels hot water, it has to get there very rapidly in the cooling process to form the uranium radiohalos around the tiny crystals. At the same time, it has to supply radon and radon to the infiltrating hydrothermal fluids that are under pressure, that carry the radon and polonium along the cleavage flakes adjacent to the uranium radiohalo that's forming. It concentrates the polonium in new radio centers, perhaps where there's a stray sulfur atom in the cleavage planes, which decays. The polonium then decays, and then the sulfur atom is free to grab more polonium from the transporting hydrothermal fluids, which is then replenishes the polonium, which decays more until the polonium radiohalo forms. Okay, transported, picks up polonium on a sulfur atom, which decays. More polonium comes along, which grabbed by the sulfur atom, which decays until you form both uranium and polonium radiohalos concurrently at the same time, while there was accelerated nuclear decay of uranium, producing all that polonium rapidly before it could decay, transported by the hydrothermal fluids. The granite had to form rapidly. The radiohalos had to form rapidly. So, the evidence of rapid hydrothermal fluid transport of the polonium forming adjacent to adjacent polonium radiohalos You've got short half-lives, the polonium polonium atoms, short transport distances, the bubbles at the centers of the radiohalos, the polonium radios are now empty. They were fluids originally. The greater numbers, and it's being shown by the research that the greater numbers of polonium radiohalos are where there are greater volumes of hydrothermal fluids. I predicted that, and there's multiple studies that are in the literature where I showed that where there was more hydrothermal fluids, there was more polonium radiohalos. We don't have got time to go into that, but we can conclude that dark uranium radiohalos in many granites and schists around the world are observable physical evidence that abundant nuclear decay had occurred at least 100 million years worth at decay's rates, and that the coexisting uranium-polonium radiohalos in these many granites and schists all around the world had to form at the same time, and so are observable physical evidence that this abundant nuclear decay had to have occurred at an accelerated rate. So an accelerated radioactive decay would be expected to generate enormous amounts of heat, potentially causing a major heat problem that might melt these rocks. However, notice this, but because it has been observed and experimentally determined that radiohalos can form only under 150 degrees C, therefore, the fact that they have survived this accelerated decay means there could not have been a heat problem. Otherwise, no radiohalos would have survived. Now, finally, radiocarbon. What is radiocarbon? Well, radiocarbon 12 is stable carbon 12, stable because it's got 12 particles in its nucleus. Carbon 14 has got 14 and it's unstable. Okay, and therefore it has to spit out some of those, spit out a particle from within the nucleus to reduce its size to become more stable. Now, this is how the method works. Cosmic ray bombardment in the atmosphere from outer space generates high energy neutrons, which bombard nitrogen in the atmosphere. Up to 70% of the atmosphere is nitrogen, which captures these neutrons, so they become carbon 14. That carbon 14 combines with oxygen to form carbon dioxide, which permeates down in the lower atmosphere, where plants absorb the carbon 14 in carbon dioxide when they use it for photosynthesis. The animals absorb that carbon 14 when they eat the plants. So they keep on adding carbon 14 until it decays. When the plants and animals die, they stop taking the carbon 14. So the carbon 14 in their buried remains decreases over time. The older the remains are, the less carbon 14 atoms they contain. So if we can measure how much carbon 14 is buried in the animal and plant remains and compare that with the amount of carbon 14 in the bones of living animals and plants, and then if we know the decay rate of carbon 14, then we can calculate how long ago the animal died, plant died, by how many carbon 14 atoms are left compared with the amount of carbon 14 atoms today and the decay rate. So that becomes the carbon 14 age of those bones or buried plants. Buried plants, say, in coal beds, because coal beds are made up of plant remains. Okay? So carbon 14 decays back to nitrogen 14 at a steady rate which can be measured. Its decay rate is expressed in units of half-life, which is the time taken for half the original amount of atoms to decay. The half-life of carbon 14 is about 5,730 years. So that means if we originally had a pound of carbon-14, after 5,713 years, we have half a pound left. So that means with carbon-14 decay, the aging, the content rapidly decays, the amount gets less and less. So that means after 6 half-lives, we have very little carbon-14 left. It means that after 10 half-lives, there's virtually none left. Ultimately, it means that if every atom making up the Earth were carbon-14, within a mere million years, there would have been all the carbon-14 would have decayed away. So if a fossil is truly millions of years old, then it should contain no radiocarbon. The secular conventional scientists say, therefore, the fossils should be radiocarbon dead. So, since the early 1980s, since the development of accelerator mass spectrometers, instruments which give you the best radiocarbon dating results, they've routinely checked all this. How have they done that? Well, we'll see in a moment. The detection limit of these accelerator mass spectrometer instruments are so good that if only 0.001% modern carbon is left, it can be detected. That's equivalent to an age of 95,000 years. Now, that's theoretically what could be detected. In practice, the method can only go back to about 70,000 years. Okay, and there's a reason for that, because of the laboratory background that they've calculated. How have they calculated that background? Well, they're concerned about laboratory contamination and field contamination, which would swamp small amounts of carbon-14 in samples. So they had to look at what they could detect in the laboratory. So they took samples of various fossil material. In the laboratory, samples are usually treated with harsh pre-treatments of strong acids and alkalis, which have been demonstrated to remove contamination. And then they've analysed samples that are supposedly millions of years that should contain no radiocarbon to see if they were truly radiocarbon dead. And what did they find? Samples of coal, oil, natural gas, limestone, marble, and fossils. Every sample tested contained detectable radiocarbon, which they then said was laboratory background. But wait a minute. They even put empty sample holders in their instruments and got a zero result. So if there was no sample and it gave a zero result, zero should have been the laboratory background. But instead, these coal, oil, natural gas samples giving a result, they assumed that must be contamination intrinsic to the instruments. But wait a minute, the samples were treated with hot, strong acids and bases, alkalis alternately, and washed, removing any trace of any contamination. Maybe the radiocarbon is intrinsic to the samples. Okay? Every conventional measurement on organic materials, supposedly up to 540 million years old, detected radiocarbon. But because of their bias, because the samples were supposedly millions of years old, they assumed that there would be no radiocarbon. Therefore, they assumed that this had to be contamination. I even took fossilized wood samples from various locations up to 250 million years old. And I always I sent them to the laboratory blind, and they measured the radiocarbon, and guess what? Radiocarbon ages of only thousands of years. Here, a wood sample, supposedly 189 million years, from its geological context, gave a carbon-14 age of only 24,000 years. Or this fossil wood from a coal bed, a coal layer in Newcastle, Australia, supposedly 250 million years old, gave a radiocarbon age of only 33,700 years. And here's a fossil ammonite with fossil wood near Redding in California, supposedly 112 to 120 million years old. And look at the carbon-14 ages, over 40,000 years only. Further research we did confirm the presence of measurable carbon-14 in different coal beds. 10 coal samples from around the US from different coal mines. The coal samples were taken by the Department of Energy. They were quenched with argon and stored in special bags under an argon atmosphere, under cold control conditions. The contamination had been eliminated by careful storage, careful treatment and storage. We obtained samples from the Department of Energy from 10 coal mines around the US, and these had conventional ages from 40 to 320 million years. And yet, when the samples were analysed for carbon-14, they gave an average carbon-14 age of 48,500 years, which makes sense from the flood, because these were all trees that lived at the same time and died at the same time at the beginning of the flood. Here they are, from all these different coal mines, coal seams, coal beds all around the US, all had essentially the same radiocarbon age because they lived at the same time before the flood came and died at the same time when the flood came. Here they are. We also took cut diamonds, 12 diamonds from various deposits in Africa, and all the diamonds had measurable radiocarbon ages. Now, here they are, from diamond deposits around Africa. This could not be due to contamination, either external or internal, because diamonds are impervious to contamination. The diamonds, the radiocarbon could not have been produced in situ by bombardment of nitrogen in inclusions from uranium and thorium, as skeptics would say. Why? Because the in situ nuclear bombardment, neutron bombardment, wouldn't have produced the levels of carbon-14 that were actually measured. We actually did not only the measurements, but the calculations. So anyone who claims this radiocarbon in the diamonds was due to neutron bombardment of nitrogen 14 hasn't done their homework. These initial results were confirmed independently by UC Riverside on their own diamond samples, and they published their results in the literature. These diamonds give conventional ages of 1 to 3 billion years, yet their standard radiocarbon ages, corrected for a stronger Earth magnetic field in the past and other effects, give you corrected carbon-14 ages less than 10,000 years. Now, the diamonds formed at least 100 miles down in the Earth's mantle. They therefore contained radiocarbon that didn't come from the atmosphere. That was radiocarbon intrinsic to the radiocarbon, to the diamonds when the Earth formed. So that means the diamonds formed in the mantle when the Earth formed. So the Earth and the diamonds are only thousands of years old. So that means that if we take those radiocarbon age for the wood samples in the coal beds at 48,000 years, a half thousand years, at the flood only 4,500 years ago, we can recalibrate radiocarbon. There are a number of known ways in radiocarbon can be affected. Atmospheric variations between atmospheres. This is documented in literature. Variations in the natural carbon-14 production rate, effects of human activities on carbon-14, burning of fossil fuels, nuclear testing, fractionation of carbon, in situ production of nitrogen from nitrogen-14, recrystallization of carbon in shells, the marine effect, volcanic eruptions contaminating, putting carbon-14 into the atmosphere. However, the biggest known factor is the cosmic influx rate is controlled by the Earth's magnetic field. We know from real-time experiments over the last 200 years that the decay of the Earth's magnetic field, its energy, has been lost, halved at a mere rate of every 2,000 years or so, which means a stronger decay rate in the past. A stronger magnetic field means less carbon-14 produced in the atmosphere, which means that the radiocarbon ages assumed decay, calculated using today's decay rate would give you too large an age. And we can demonstrate that by pottery. The magnetic signature in pottery shows that the energy was much higher in the past. We have to correct the radiocarbon ages, which have been demonstrated by the archaeologists to be much older than the true historic archaeological ages. So, meaning that radiocarbon ages calculated assuming a constant magnetic field give you grossly inflated ages back beyond about 1000 BC. So carbon-14 is not reliable, but, okay, it means that in thousands of real years, we have millions of years of radioactive decay. Because it means that granites dating from the flood are truly only 4,500 years old based on radiocarbon ages that have been recalibrated. So that means there had to be accelerated decay based on radiocarbon. So let's wrap this up. All three crucial assumptions on which the radioactive decay methods depend all show that they're unsustainable and unreasonable. Inheritance and contamination in rocks are common when it can be detected, which begs the question as to how sure we can be that there's not also common in rocks of unknown age. And decay rates have been shown not to have been constant in the past, but accelerated by some past catastrophic event. So if all three assumptions are unprovable and demonstrated to be falsified, then all the radioactive dating methods are subjective to the same uncertainties. Inheritance, contamination, and non-constant decay rates make all radioactive decay methods totally unreliable, unusual. The bottom line is that none of these dating methods are reliable, independent, or objective. Therefore, the radioactive dating methods cannot provide absolute ages for rocks and meteorites. Thank you very much.
Thank you, Dr. Snelling. I appreciate that. That was an awesome presentation. I really enjoyed that. All right, I have here, looks like an hourglass, but it actually only lasts about 10 minutes. But I've been kind of like flipping this up and down the whole time. like this way, and because it don't last very long. But
Well,
you
you
guys
keep on
didn't actually
you keep
go
on
ahead.
resetting the clock. You know,
Right,
what if you had a rock layer, the clock started ticking, and then there was a thermal event that affected the rock layer? It's going to reset the clock.
right. And essentially, that's what you've been saying at the beginning and during the presentation. You don't actually, since we're not actually present to see the conditions that this was exposed to, what you're assuming is that the amount of sand and the amount of sand that's in the bottom and the flow rate, and then you measure the flow rate, and you assume that all the sand at the bottom came from the sand at the top at a
Correct.
set known flow rate. And so, but how do you know that it hasn't been contaminated? How do you know that the additional radioisotopes hadn't been added? How do you know that the decay rate was always that particular rate of decay? Um, I would like to start by asking a question on. I've heard some people say that there's a decay law. Does the decay law, and they use that to try to argue that the constancy of the decay, and of course we're going to probably get into whether or not if accelerated nuclear decay violates some sort of laws of physics and that sort of thing.
Yeah. Well, it has been demonstrated both theoretically and experimentally that if you change the strong and weak nuclear forces holding the nucleus together, that you can change the decay rate by orders of magnitude. Experiments have been done with radium. There's a study in the literature which shows that if you affect the conditions under which the decay is occurring, you can actually change the decay rates. It's also been demonstrated or experimentally measured by silicon coming from the solar from the sun. There was a paper a few years ago which showed that the decay rate of silicon was affected in the solar wind from the solar particles coming off. And so you only have to change the strength of the binding energies of these atoms, in these particles, I should say, the neutrons and protons in the nucleus, that you can affect uh, the decay rates by orders of magnitude. That's been demonstrated both theoretically and experimentally, and that there's studies in the literature. And this was also published in those two rate volumes and in papers subsequently. So there's no excuse. It's in the conventional literature as well as in the creation science literature, and it's well known. And it's all very well saying that there's a physical law, but there are assumptions in that physical law about the conditions under of the binding energies of these nuclei, and those are only assumptions. As soon as you start playing with those assumptions and changing the conditions, and were the scientists there in the past to see whether those conditions were always the same, the binding forces, have they always been the same, or have they been changed? Now, you know, um, it's not. We get accused of bringing God into the equation. Well, of course, we're creationists. The Bible says in the beginning, God created. Well, we read that on a certain day of a certain month in a certain year, the fountains of the great deep opened and the flood began. Well, that means that God must have known exactly when the flood would begin, and therefore he triggered that. So God is still part of the equation. Noah didn't close the door, God closed the door. Noah didn't bring the animals, God brought the animals. God brought the wind. That's all implicit in the Bible's description of the flood. And I unashamedly say, regardless of the skeptics who are assuming that God is never involved in Earth history, Well, I hate to say it, the Bible says that God was involved, and the very atoms are held together by Jesus Christ, the Creator. So, if Jesus is capable of turning water into wine, he's capable of changing the binding forces in the nuclei to generate radioactive decay more rapidly, to generate heat, to cause the fountains of the great deep to burst open to begin the flood. And he's capable of protecting Noah and the ark. So, all these cards are on the table, and yet we can show that there are physical ways in which decay rates can be accelerated. And we can show from experimental results that the different isotopes were give different results depending on their atomic weights, and therefore the binding forces affected the decay rates by different amounts according to the atomic weights of uranium versus potassium, to give you totally different ages that indicate acceleration at different rates. I mean, we're talking about a lot of experimental data and known principles documented in the literature.
Now, you talked about polonium halos and things like that, and on uranium 238. There is a critic on my channel who often brings this up. He calls it the Big Four. You know, the radium 238, radium 235, thorium 232, and potassium 40. Now, of these four, three of them are beta decayers, specifically. What was it? No, alpha decayers. Is that right? Yeah, alpha decayers. Um, Radium 238, radium 235, and thorium 232. And the claim is that these can only be affected, by the, nuclearly. It can't be affected by environmental conditions and that sort of thing. And so they said that no matter what we throw at it, this is what's been argued by the critic. He said no matter what we throw at it in the laboratory experiments, they do not change the decay rate. What would you
Not
say to that?
not correct. Not correct, because a byproduct of uranium decay is radium, and radium has been experimented in the laboratory, and it's been shown that the decay rate can be changed by changing the environmental conditions. So he's wrong, because that's one of the decay steps from uranium 238 and uranium 232 and uranium 235 and thorium 232. Radium is in those decay chains, and it's been demonstrated that radium can have its decay rate changed. No one has done all the experiments yet, simply because people aren't asking the right questions to do the experimental work. Just because he claims that it can't happen is simply because nobody has done the experimental work and done it, and it's documented in the literature. So it's an argument from silence. And the reason why the experiments are being done is because people don't want to and haven't done those experiments, because they're content with assuming that the decay rates can't be changed.
Right. And you also mentioned the what's the so-called heat problem that people often argue for, and you said that the polonium halos show evidence that accelerated decay had occurred. I think you said 500 million years or so worth of accelerated nuclear decay had to occur, but yet these null under like 150 degrees Celsius, I believe you said, and
Yes.
so would you say that this is proof positive that that accelerated decay occurred, but there was that either the heat wasn't an issue or the heat that was generated? What you said in the rate volumes,
Well,
you said that the heat that it could have had a mechanism that moved fast enough to remove the heat.
yes. Well. Let's step through this carefully. What's the evidence? Well, I showed you that drill hole in New Mexico where the samples were taken for helium measurements, the amount of helium that was retained in those zircon grains. Well, those same samples were also looked at for radio halos. And they found that once the rock had got to 150 degrees, the halos disappeared. And then experiments were done heating up rocks to see what would happen to radio halos, and they disappeared once the rocks got to 150 degrees. So we know that when we take samples and find radio halos, that means those rocks had to be, those radio halos had to form after the rocks had got to at less than 150 degrees. Well, if that's in a granite, the granite starts out at 650 degrees. It's got to cool to below 150 degrees so quickly, very quickly, so that the uranium is still producing enough polonium to produce the polonium radio halos after the rock falls below 150 degrees. But what does that also mean? As the granite crystallizes, what happens? We know from experiments that it spits out water, hot water. Hot water not only transports the polonium, but it also transports heat. We saw that in that granite that intruded into the schists and amphibolites in Colorado. What did we find? The heat and water from the granite traveling out into the surrounding rock affected the surrounding ages. We know that around granites is what we call a metamorphic aureole. That is where the heat and the hot water has affected the granite. We can demonstrate, and a colleague and I have done the work on that and looked at the literature. We can demonstrate that the water in the granite, it fractures the granite, it creates pathways, and it carries the heat out very effectively. In the crystals of biotite, between the sheets where the polonium is being transported by hot water, we often see the alteration effects of the heat of the biotite flakes. Yes, there had been heat, but the water was carrying the heat out so quickly that there was still time at lower temperatures, below 150 degrees, to form the radio halos. So these were very rapid process. Heat moves things very quickly, yes, but it takes out the heat away. Also, there's evidence that the heat was extracted from hot water from the fountains of the Great Deep. Heat would have been transported up into the upper atmosphere and expelled out into space. There's a number of mechanisms that are being proposed, and more work definitely needs to be done on this. But the very existence of the coexisting uranium radio halos in rocks that are pre-Cambrian, pre-flood, and rocks that were formed during the flood, and even rocks that were formed at the end of the flood. I've taken samples from all around the world at all different levels of the geologic column, and they all contain observable polonium and uranium radio halos, meaning they're both evidence for rapid accelerated decay to produce the polonium radio halos and rapid cooling of the rocks so the radio halos can form. In other words, there ultimately has been no heat problem.
Absolutely. Um, the Either way, whether you're not saying that these didn't generate any heat, what you're saying is that
No,
whatever,
no.
but
Whatever heat
whatever
was
happened had
generated, there
right.
were mechanisms
Now,
for removing that heat.
okay, relative to this, I have heard critics try to use YEC quotes, from the Break Project to try to argue, therefore, since we don't know what could have removed the heat, therefore the heat, there must not, we must not have a mechanism for removing the heat. But that's like an argument from ignorance. What you're not saying that there was no mechanism. What you're saying is that there was a mechanism, but the fact that we don't know what it is exactly does not necessarily mean that
Well,
it didn't exist.
well, remember two things. With the rate project, we had an end date. So we had a deadline to finish our research. We also had to a publishable size volume. I mean, we could have kept on doing research and built a bigger volume, and we did. And that subsequent research has been published elsewhere. Russ Humphreys and Eugene Chaffin have both published papers relevant to this heat question and shown that there is no problem. And in the rate volume itself, I already talked about the existence of the radio halos, meaning that there was no heat problem. And so, you know, for critics to come along and argue that there was nothing said in the rate project, that's utter nonsense. And if you search the literature since the rate project, you'll find relevant papers subsequently published to this whole issue in the Creation Research Society Quarterly and proceedings of the International Conferences on Creationism. There have been papers that are relevant to this whole question.
Right. I actually have had Dr. John Baumgartner on my channel before twice. Once to discuss the CPT model, and the other time to discuss C14 in diamonds, which we're going to be talking about here in a little bit. Um, and he's also talked about the research, further research that's been done. Now, I knew this also from reading stuff that y'all produced since the Ray Team project closed. So the interesting thing about this whole thing is that we don't just have y'all what y'all did in 2000, back in the late 90s and early 2000s to go on. Y'all have actually been doing research. Every one of y'all has been doing research since then, and
Mm-hmm.
there's been studies that have been done on that. So it's not like that. This is out of date stuff. This is stuff that's still being worked on. This
Yes,
y'all still continue to write papers on this, and continue to do studies on this. I heard that C14 has also been looked at
absolutely.
since then in like coal samples and stuff. So it's very interesting the fact that y'all continue to work on this. This is not something that had to end in 2004
No,
and no
in fact,
more discussion of it. So
even
it's
today,
awesome. Go ahead.
I mean, you can go to the Answers Research Journal and you will find papers in the last year or two talking about recalibrating radiocarbon. And even today, a paper has just been finalised for publication in the Answers Research Journal. It's still got to be typeset, but within the next few months. And it's got a recalibration curve for radiocarbon based on data that's in the open scientific literature, as well as modelling work from the RATE project and other projects. So, this is an ongoing issue of study. These are ongoing issues. And what I find, Brian, is that many of these skeptics and critics take things out of context. First of all, that's one thing they do. And secondly, they don't keep up to date with the creationist literature. And so they're arguing from ignorance.
Right. Absolutely. Um, And I'm going to ask you some questions on Polonium Halo. I know that I've actually had critics that that like what you said about the heat within all these Polonium Halos. So they sit there and say, see there, that must not mean the accelerated nuclear decay had occurred. But then they kind of forget the other half of your argument that actually shows that accelerated nuclear had occurred. So it's kind of like where they cherry pick the part where you said that this would be annulled under certain temperatures, but then forget about the part where this is evidence of cellular decay. So you're not saying, so in other words, this shows that cellular decay did occur, and that the heat, whatever heat was generated, assuming it generated, then it would have gotten rid of really fast.
Correct.
You mentioned something to me in email that I've always been curious about as well. You said that there is a research that's being done that some people are thinking that maybe there was no hardly any heat generated at all. Do you want to explain that one?
Yeah, it's the whole point is that we don't see the evidence for heat. There are mechanisms with the fountains of the great deep um, taking that heat out. Um, I'm not saying that there was no heat generated. I'm just saying that we're confident that there are mechanisms by which the heat would have been dealt with. And so remember that the flood was a watery event, and the heat that came out under the flood waters raised the temperatures of the ocean waters, and even the secularists know that ocean waters were a lot warmer in the past than what they are today. So they absorbed a lot of heat, and the fountains of those great deep supersonic steam jets that John Beauregard would have talked about was capable of taking a lot of heat up into the atmosphere. So modelling work is still to be done to pin down some of these issues. We've just got so few people trained with the necessary tools to be able to do this work, and it just takes time to do it.
Right. And you also mentioned something that you talked about in the email as well during your presentation about how the speed of accelerated decay is actually affected by a variety of different factors. And you said C14 would hardly decay very fast at all. One of the criticisms I've heard, as you know, is that if exonuclear decay had occurred, all the C14 would be gone. But that actually betrays the very
Yes,
research that has been done on this.
that's right. Our research showed that there was a systematic pattern, and that's why I emphasised that during the presentation. The smaller the nucleus atomic weight, the less was the decay accelerated. So potassium with a smaller atomic weight to uranium, it was accelerated less. And so this means that carbon 14 with a half-life, with a nucleus of only 14, atomic weight of only 14 compared to a uranium atom, 238, would have hardly had its acceleration rate affected at all. It was an exponential factor, and we saw that during the rate project. I mean, look at the discrepancy between potassium and rubidium in the Cardenas basalt. The age was half that of the rubidium. There's also the half-life. It was the atomic weight was a factor. The half-life, the slower the half-life, the greater the accelerated rate, and also the mode of decay. Potassium and rubidium, which were always younger, decay by the beta process, whereas samarium and uranium decay by the alpha process, and they always gave older ages. So there are a number of factors: the mode of decay, the rate of decay, and the atomic weight of the nucleus were all found to be factors. The overriding factor was the atomic weight, and those skeptics who say, oh, all the carbon-14 should have decayed away, haven't read what we said. Carbon-14 would hardly be affected by accelerated decay because it has such a small nucleus, small
Right.
carbon atomic weight.
You also use an argument that I commonly use as well. One that talks about the strength and weakening of the EM field,
Yeah, well,
because in the past that would have been stronger.
yeah, carbon-14 is also produced by a different process. You know, the uranium and potassium are intrinsic to the rock when it forms, whereas carbon-14 forms in the atmosphere as a result of cosmic ray bombardment. But that cosmic ray bombardment is affected by the strength of the Earth's magnetic field, a stronger magnetic field in the past, less carbon-14 production because there's less cosmic rays getting through to bombard the nitrogen 14 atoms to produce carbon-14 atoms. That means that plants and animals living 1,000 years BC were getting less carbon-14 in their bodies than animals and plants living today. And so that means if we assume the same levels as today when we calculate the ages from the measurements, we're going to inflate the ages. And so that's the
Don't in
basis.
well, I was gonna say, don't in C14 C12, don't they use like a C14 C12 ratio or something like that? And this would throw the ratio off if the EM
Oh
field
yes,
was
that's
stronger in the
right,
past.
exactly. It also it also means that if you have accelerated decay, um, if you're going to have um, less carbon 14 and more carbon 12 in the pre-flood world, then the carbon 14 that's buried in the plants in the coal seams is going to swamp the carbon 14 that's generated by decay subsequently. So there's a number of factors that are going to inflate the carbon 14 content compared to what we see today. That's going to inflate the ages, I should say.
Some people have argued on potassium 40 inside people. Said if accelerated decay occurred, and then the like C14, C12 that's inside of us or whatever, or inside Noah at the time of the flood, it would have killed them or something like that. Um,
That's
so
that's assumed.
what? What? Okay.
No, as I say, that's assuming that the environmental conditions were the same in the pre-flood world as they are in the post-flood world. But let's remember that the pre-flood world began perfect. In the Garden of Eden, there was no potassium 40 in the ground. There was no uranium 238 in the ground or in the body of animals and plants and people because it was a perfect world. Uh, God, there was no harm caused because there weren't those radionuclides in that environment. Then we had the curse, but still the curse did not affect the amount of carbon 14 in the bodies of animals and plants, or potassium, or uranium. At the flood, however, there was a total change in the Earth's atmosphere and in the Earth's environment. Now we suddenly have accelerated nuclear decay. We have new granites form. We have isotopes moving around, stirred, etc., and it's going to change. Also, remember that during the flood, Noah was with the animals in the ark, made from wood from the pre-flood world, in bodies from the pre-flood world that didn't have those isotopes, and there was water that shielded them from the radiation that was being produced in the rocks that were forming, hundreds of feet down below the water. I mean, what do they use to shield a nuclear reactor to protect the workers? Water. Water
Yeah.
shields nuclear reactors. So water
Right.
shielded the ark and the animals and Adam in Noah in the ark from what was going on in the world that was being affected by the flood below the waters. And so we have to see that there can't have been environmentally the same amounts of these isotopes in the pre-flood world, in the bodies of animals, plants, and people, as in the post-flood world. And by the way, if you look at the biblical account of the ages of the patriarchs, prior to the flood, they lived on average over 900 years. And then after the flood, there's a very rapid decline. That would have been due to the genetic bottleneck at the flood and also a change in environmental conditions in the post-flood world. Now, after the flood, there was more environmental radioactive decay and radioactive activity, which affected the tissues of humans and animals and plants, which meant that humans didn't live as longer. And we see that in the rapid drop off in the patriarch's ages after the flood. So we've got all that evidence to show that it wasn't a problem in the pre-flood world, and it wasn't a problem in the bodies of the animals and people in the ark.
Right. And just to kind of clarify to everybody else on the what he was saying on the floodwaters, water has a very high specific heat capacity, and so this would have the total heat capacity would increase based on the amount of
Yes,
water there, and so that would have actually created a really powerful thermal buffer that would have protected Noah from all that radioactivity happening
absolutely,
inside the earth.
absolutely,
So
absolutely.
yeah,
And by soaking up its heat, it would also have helped them to cope with the conditions during the flood.
absolutely.
And
Um,
also we have to remember it wouldn't have affected the air pressure and therefore the amount of oxygen they were breathing, because air pressure is relevant to the atmosphere, not the level of the water.
right. On polonium halos, some people think, or some critics have argued, hydrothermal transport of polonium from uranium-bearing sources would be able to explain it. How would you respond to someone who thinks that?
Um, you got to move it fast enough. And I showed in my, I went to the Great Smoky Mountains. Okay, in the Great Smoky Mountains, if you go on the main road from Gatlinburg across the mountain to the other side in North Carolina, you go through metamorphic zones. The sandstones have been metamorphosed, and you go through zones of regional metamorphism with index minerals that define the temperature and pressure conditions. You go from the biotite zone up to the garnet zone, to the staurolite zone, onto the kyanite zone, and this is well known, well documented. And I took samples of these sandstones, and I predicted that where you went from the garnet to the biotite, the garnet to the staurolite zone, there was a well-known metamorphic reaction that produced a lot more water, and therefore you'd expect a lot more radio halos, polonium radio halos, at that transition over zone. What did I find? You can read about it in the study I did. Prediction was confirmed. I predicted repeatedly that where there was evidence of more fluid flow, so for example, I looked at ore deposits that were formed by hot water deposition in here in Australia. And I took samples from away from the ore deposit to near the ore deposit. And guess what? There was a lot more halos where you had the deposit from the fluids that formed the deposit. And so, yes, there is a correlation between radio halos and hydrothermal fluids, and they transported the polonium, but it had to be fast enough to produce the radio halos. And that means the water has got to go into the granite. But water doesn't go into the granite from lower temperature to higher temperature. The granite is at the higher temperature. The hydrothermal fluids will go from the higher temperature to the lower temperature zones. And so you're not going to be taking hot water into the granite to take the polonium into the granite. You're going to be taking the hot water out of the granite and taking the polonium out of the granite through the zircon crystals within the granite, within the biotite flakes to produce the radio halos. And it's the same
This
within the
point,
schist.
well, go ahead.
No, it's the same within the metamorphic rocks.
All right. This next question I've heard, I think I've actually heard critics actually say on my channel. Skeptics have argued that reported orphan polonium halos may actually have parent radium halos that are difficult to identify. How do you respond to that particular criticism?
Well, I've never heard that because, yes, we do find polonium radio halos with no uranium halos nearby. That is in the same crystal, but we find uranium halos in the same rock in other crystals. So the question is really asked from a state of ignorance,
Right.
not having done the homework to study the rocks in question. The polonium, yes, we can find orphan halos in the crystal, in the microscope view, but we move our sample under the microscope, and we eventually do find uranium sources nearby in uranium radio halos. So it's an argument that's from people who haven't done their homework.
Right. Right. Um, there is a guy. I think his name is Dr. Collins or something like that. Um, he see creates more problems than it solves, particularly regarding um.
Yeah, Lawrence
Do
Collins.
you? Yeah. Okay.
He
Do you know? Are you familiar with his argument, and what is your
yeah,
response
he
to it?
says he says that they are really radium and radon halos, and that the granites don't form by that process; they form by a different process, which produces a feature called myrmekites. Well, two things. First of all, these halos have been accurately identified not as radium and radium radar halos. We actually measure the diameters, which are related to the energies. And so we can demonstrate that the radium and radon are different, that the polonium have distinct radii and diameters. And so these are truly polonium radio halos. So he's wrong on that account. And secondly, most geologists do not accept myrmekites are not found in most granites. Um, and so his idea of granitization has been discounted over and over again in the literature. Myrmekites are not found in all granites. They're found in very few granites. They're found in very localized situations that are related to the fluids affecting sedimentary rocks to produce granites. And so his whole argument falls apart based on what we read in the secular literature. Even his secular colleagues don't agree with his granite formation model. And so, he refuses to accept that his arguments have been refuted time and time again, even by many of his secular colleagues.
Right. Did you mention fission tracks in your presentation? I can't remember if you mentioned those.
No, I didn't mention fission tracks at all. That's another evidence that we could have presented. Basically, there are more fission tracks, which are physical evidence of decay, more fission tracks in the deeper, older rocks than in the younger surface rocks. And by the way, Brian, it should be mentioned here, people have said, I've just answered this recently, a biologist of all people trying to tell us that if all the decay, all the rocks were formed during the flood, they should all give the same age. Rubbish. A lava flow in the first month of the flood would have suffered from nearly a year's worth of accelerated nuclear decay. So it would give a very old radioactive age, compared to a lava flow erupted in the last month of the flood, which had only suffered a month's worth of accelerated nuclear decay and therefore would give a younger radioisotope age. And so he's proven wrong based on the ages published in the literature. And it's the same with the fission tracks. We'd expect fewer fission tracks in a younger volcanic ash bed to an older volcanic ash bed formed earlier in the flood. And that's what we found with the fission track evidence. And so that also is evidence of accelerated nuclear decay, because the fission tracks in the older volcanic ash matched the radioisotope ages, and it did with the younger one. Fewer fission tracks, younger fission track age, equivalent to the same younger radioisotope age. And so the amount of physical evidence of actual decay having occurred, fission tracks matched the amount of decay that produced the radioisotope ages, but all within the flood year. Therefore, the decay rate had to be accelerated.
Right. Um, you mentioned inconsistent isochron ages they were given for the rocks and stuff like that, and you also mentioned that Austin, your colleague, Dr. Steve Austin, had also been criticized for this by critics, claiming that that you can't date rocks of a younger age. And of course, as you mentioned, this is actually was done in the literature by secular scientists. And as far as I can tell, this kind of criticism didn't come until after the Rate Project came out. But they
Correct.
didn't criticize all the secularists that were doing
No,
it
no,
prior to
no,
that.
no. And they were potassium argon model ages, separate from isochron ages. But here's the point: after that study that was published in 1996 of the dating of the Mount St Helens eruption, the lava from the Mount St Helens, giving you those ages up to 2.6 million years. Okay, one of the critics, and I can mention his name because it's been mentioned openly, was Dr. G. Brent Dalrymple, who used to be the deputy director of the US Geological Survey and then left to join the UC Berkeley Geochronology Center. He criticized Steve Austin for using the wrong method to date the rocks. You shouldn't use potassium argon methods and not sampling correctly. Well, back in 1966, G. Brent Dalrymple had a paper published on 26 historic lava flows that he dated using potassium argon dating, published in Earth and Planetary Science Letters, which is a very well-known conventional science journal. And one of those historic lava flows were the Hulapide basalts near the Kona Airport on the Big Island of Hawaii. So for Dr. G. Brent Dalrymple to be criticising Steve Austin is the pot calling the kettle black. If it's good enough for the
Uh,
secularists to use potassium argon dating to use on young lavas and young samples, then it's okay for creationist scientists to do it as well.
right. One criticism that I've heard on that was that they claimed that the daughter isotope hadn't had time to, or there is no daughter isotope, or I can't exactly remember whether they argue for 0% daughter isotope
Yeah, they would say there
or
wouldn't be
they
enough.
arguing for
There wouldn't be
right.
enough time for enough argon 40 to accumulate, and they're right. But there was argon 40, which means it was inherited, which is the point. It was the point that G. Brown Dalrymple and others made in the secular scientific literature, which is exactly the point that we are making with the dating of the Mount St Helens lava flows. And the point that I was making with the similar potassium argon dating of the Mount Narahoe historic lava flows, that there was inheritance of argon 40 from the volcanic gases during the eruptions. End of argument. We
Right.
all agree.
And
Inheritance.
right. I heard that that of course they've used it on was it Mount Vesuvius, and that's like only what about 2,000 years of
Ah,
time,
yes, but first of all, they use the argon method, not the potassium argon method.
right?
They use the argon method, which is different. And let me unpack that for you a minute. Argon works on the fact that they irradiate the sample in a neutron flux in a atomic reactor, okay, to change the potassium 40 into argon that they can then measure with a spectrometer, mass spectrometer in the one measurement, okay? So different nuclear reactors produce different neutron fluxes, even different sample runs the reactors produce different neutron fluxes. So how do they work out the neutron flux factor for the argon produced from the potassium irradiated in the sample in the nuclear reactor? Well, in the sample holder, they put samples of known age to irradiate them at the same time as the sample of unknown age. Okay? So what sort of samples do they use as standards? Samples that have been measured by potassium argon dating, by other dating methods. In other words, they're using assumptions to get those neutron fluxes. Okay? Then the other thing with the Mount Vesuvius sample is that before they did the dating work, they knew what the target age was. They didn't do the analysis blind. So, first of all, they had to use standards of known age dated by other methods, which means the standard age is only as good as the ages of those other ages, and they knew what target they were aiming for. So, you're talking about a lot of bias involved
Right.
and a lot of
I heard one.
assumptions.
I heard one criticism. They say if accelerating could occur, this would change the energy industry. Have you heard that one?
How is that relevant to today? The energy industry is based on today's radioactive decay rates. Today's energy industry has nothing to do with any past accelerated decay. They take enriched uranium, put it in a nuclear reactor, and start a chain reaction today. That's nothing to do with past accelerated decay. This is what amazes me about these critics. They start clutching at these straws about which they have no knowledge, or they're taking things out of context to try and bamboozle their listeners to give an argument that seems to be valid based on assumptions or taking things out of context or pure ignorance about what they're talking about. Sorry, I have to be
Yeah.
blunt. I have to be blunt because I tell you, it is true that that's exactly what these critics are doing.
That's fine. I'm blunt. I just come out and say it. That's right. Um,
Absolutely.
One of the things that I've often heard, and I think me and you talked about this a little bit when we did our response to radiometric dating, but a lot of critics will say that and that you can't that the major oil companies rely on the accuracy of radiometric dating to find and drill for oil. I actually had an entire video. This was awesome. I had an entire video with Dr. Timothy Clary and from Institute for Creation Research because he was actually part of a major oil company. He said, no, that's not true. He said, there's like four different things that they go into finding and
Correct.
drilling oil. It has nothing to do with age of the earth.
Correct.
He said that
Correct.
he said the basic modeling is just something to make the managers happy, but you could
Yes,
actually technically factor in a young Earth position, and it would work just
exactly.
as
And they're
well.
looking they're looking at the vitrinite reflectance, that is coalified material in sedimentary layers. The light reflects off the polished surface of the coalified material, and we know that a particular reflectance value is where you've got the oil generation window. If it's higher than that, means that the rock has already had the oil driven out of it. If it's below that window, the rocks could still contain oil, and therefore it's being generated in that basin. Let's go drill. Nothing to do with the age of
Right,
the rock at all.
right. All right. Helium retention
And
size
the
zircon
same
crystals.
the
Or go
same
ahead.
can the same can be said about uranium deposits and other ore deposits. The reason why I was doing the research with the scientists, I was collecting soil samples over the deposit to look at the lead isotope signatures, right? And the groundwaters, because we want to go from the known to the unknown. And so we went to another location, sampled the soils, and discovered where there was another uranium deposit based on the amount of lead in the soils. We couldn't detect the deposit near the surface, but we could in the soils. Or we collected leaves and looked at the lead isotopes in the leaves because that was deposited by the waters that they were pulling up, the groundwaters. And we demonstrated that where there was ore, we had higher. And so you go from the known to the unknown. It has nothing to do with the age of the ore. It has everything to do with environmental indicators of the ore from where you got known ore deposits. You go and look where you got unknown areas to explore for those same environmental features that might indicate there's an ore deposit there that we hadn't discovered before. Nothing to do with the age.
Right. Um, Next, I want to talk about helium retention inside zircon crystals. You mentioned that Dr. Russell Humphreys actually published a. You said that they published it ahead of time, a prediction on how much
Yes,
would be there if it's
in the
6,000 years.
2000 rate volume, we published the prediction as to where the helium diffusion rate would lie, and then we did the experiments. And guess what? The result, and their experiments were done blind and done at a lab where we didn't control what was done. We just told them to do the helium diffusion work and report the results to us. And then we plotted them. And guess what? They plotted exactly. Anybody could take the same data and do the same plots.
Would you say this is very powerful evidence for exonuclear decay because it has
Absolutely.
6,000 years worth, but yet it dates to billions of years?
Correct. It dates by uranium lead to 1.5 billion, but by helium diffusion, which we know by a well-known physical law, Fick's law, Fick', named after the guy who established that law, observed the law for diffusion rate. And so we know that the helium diffusion age is much more reliable than the radioisotope age. And so, yes, it's a well-known property. So, um, 1.5 billion years of radioactive decay had to have occurred in 6,000 years of real-time helium diffusion, real years.
Interesting enough, I've never really heard any kind of criticism on helium. Was there? Are you familiar with any critics that have actually
Yes,
uh, tried to argue?
they tried to
Go
say
ahead.
that the biotite crystals bottled up the surrounding biotite, bottled up the helium in the zircon. Absolute nonsense, because there was higher concentrations in the zircons than helium in the biotite, and the fusion goes from high concentrations to lower concentrations. So the biotite didn't bottle it up. There's a number of arguments. Russ Humphreys has responded to all of them repeatedly.
Absolutely. Um,
I
let's
mean,
see.
you
I'm just kind of going through my questions.
just search in
Go
the
ahead.
creationist literature under Russ Humphreys' name, and you'll find the critics' objections have been published, and alongside them of Russ Humphreys' responses.
Let's talk about real quick C14 and diamonds. You mentioned that in your presentation. Um, uh, would
Yes,
you
the
say that
major,
this is pretty good evidence for
it
exonuclear decay?
is,
Go ahead.
it is, because the only argument skeptics have raised is that within diamonds you sometimes have little bubbles, and they've been demonstrated to contain nitrogen gas and some uranium and thorium. And so it's argued that the uranium and thorium decay would produce alpha particles that would zap the nitrogen 14 and produce the carbon 14. But every time people raise that argument, they've never done a calculation based on actually how much nitrogen 14 there is and how much uranium thorium is, that therefore how much decay would produce how much carbon 14. And yet, if you go to the chapter in the Rate 2 volume in 2005, and in the subsequent papers, John Baumgartner actually did that kind of calculation where he took the documented amount of uranium and thorium that might be in the diamonds, the amount of nitrogen, and did how much decay, how much carbon 14 would produce, and the amount of carbon 14 produced would be far less than what was actually detected in the analyses. And I would emphasize again, as I did in that presentation, when this work was presented at a poster in 2003 in December at the fall meeting of the American Geophysical Union, people saw that, and there were certain experimenters that went back to their laboratory at UC Riverside, and in their radiocarbon lab, they got their own diamond samples and they did the same repeat measurements and they published their results. They got measurable carbon 14 similar to what we had obtained. They did split samples, they did multiple samples, they did all sorts of things, and they replicated our results and published it in the literature. So if it's okay for
Awesome.
conventional scientists to do that, what's the problem with creation scientists doing it? It really is a worldview issue, not a scientific data issue.
Right. Um, uh, you mentioned in your presentation about some arguments that claims contamination on the C14. Obviously, there couldn't be contamination after the C14
No,
formed diamond.
diamonds are impervious to contamination.
Right.
Externally, you can't, they're the hardest substance known. The crystal lattice is so tight. There's no, I mean, the nitrogen gas in those bubbles can't escape.
Right. Uh, uh, Now, some critics claim that there was contamination, lab contamination, in the process of
No,
processing diamonds. You
no,
mentioned something
not
about
at all.
blanks or something like that. That even
No,
when they put a blank in there, go ahead.
no. When you put no sample in, you get no carbon 14. When you put a diamond in, you get diamond. We actually got them to put the actual diamonds in the holder, not prepare not prepare the diamonds and turn them into graphite. Yes, we had the pre-treatment to clean the surfaces of the diamonds. That is the hot soaking in hot acids and alternately in hot acids, strong acids and alkalis. But we didn't have the burning phase because normally the protocol, after you've done the pre-treatment, you burn it to turn it into graphite and you put graphite in the sample holder. We got them to put the diamonds itself in the sample holders to remove any possibility of contamination at that step when it was being burnt to graphite. And I
Um,
might add that the UC Riverside geologists did exactly the same thing.
right. Um, uh,
And if it was
I've also
contamination,
heard that.
they would have said so too.
Right. I also heard you mentioned the AMS machine. Also heard that the amount of the amount of C14 that was found in diamonds was actually above the threshold for contamination. Is
Oh,
that right?
absolutely. It's well above. It's well above. I mean, the laboratory where we had the work done had its laboratory threshold, and the diamond results were well above that threshold, laboratory threshold. And that laboratory threshold was determined assuming contamination when they didn't they didn't need to assume contamination because no sample, no carbon 14, harsh pre-treatments, eliminating contamination. So, whichever way you look at it, um, the carbon 14 in diamonds was real carbon 14 intrinsic to the diamonds.
Right. Um, Also, another argument, another contamination argument, is that some people claims it was argued on site, from background radiation and that sort of thing. Is it my understanding correctly that you would need a lot more than what we actually have to be able to produce the amount of C14 that's found in diamonds?
Correct, correct?
Like,
Absolutely.
was it like thousands of more times more?
Tens to thousands. I mean, the environment is not a factor at all.
Right,
Again, it's an argument. They're clutching at straws.
right. I just wanted to ask that. I knew
And
about that,
remember,
that y'all
remember
actually did
some
look into that. Go
some
ahead.
of the diamonds were alluvial and therefore at the surface. Some diamonds were from deep mines, and they both gave the same sort of radiocarbon results. So it has nothing to do with the environment. There's carbon 14 intrinsic
Right.
to the diamonds themselves.
Interesting enough, we actually found C14. Y'all found C14 in oil, coal.
Correct?
It's
No,
in dinosaur
it's in the
fossils,
secular
and it's
literature.
well above the AMS.
It's
Go ahead.
documented in the secular literature. We didn't have to document it. It's in the secular literature.
Right. Okay, if you guys want to know more about C14 and diamonds, me and Dr. John Baumgartner did a whole video on that live. So it's on my channel if you guys want to understand more. I appreciate your time. I know it's been late. We went much later than I intended, but it's fine. It was awesome. I enjoyed the presentation. Do you want to add anything additional or to let anyone know, to leave everyone with a final word concerning this matter, and relevance and importance in terms of understanding biblical authority and what secularists claim about the age of the earth, because I know that's I'll often try to emphasize critical thinking. Just because someone says the earth is billions of years old, that don't mean it's billions of years old. So
No.
so go ahead and just kind of speak some final words and thoughts that you want to leave everyone with.
Yeah, well, thanks, Brian, for this opportunity. I'm always glad to be able to help out because you're able to reach people that I can't reach. And, these podcasts go to people far and wide. And it's very important that people know that there are answers to what the skeptics and opponents are saying. And I would say that if you want to follow up more, then you can go to the websites of the creationist organizations, no matter which one you favor. But I represent Answers in Genesis. And if you go to the answersingenesis.org website and you type in some key words, you'll find lots of articles, both at the lay level and semi-technical and really technical. So, for example, you'll find lay articles on polonium radio halos that I've written, but you'll also find all the technical articles that go into all the details, the same with the radiocarbon, the same with the radioisotope dating. You can go to the ICR website, the Institute for Creation Research website. You can even download the two rate volumes. So there's no excuse for anyone, opponent, friend, or foe alike, to not having read our literature. The Answers Research Journal is available 24/7 free of charge anywhere in the world on the Answers Research Journal website, connected to the Answers Genesis website. So, Brian, there's no excuse for ignorance. The information is out there, and also the references in our papers to where all this is documented in the secular literature. There's no excuse. You go to the rate book, you'll find all the carbon 14 results, where they were produced and documented in the secular literature, as well as in our own literature. Same with the diamonds. So it's over to you. It's over to listeners. Thank you for this opportunity. May your minds be opened as you expose yourself to the literature that is available that answers all these critics and skeptics.
Right. Well, thank you again for your time. Well, we do appreciate it. And I'm hoping you're recovering pretty well from your knee surgery. I know you had that not too long
Doing
ago.
very well. Thank you very much.
All right, awesome. And glad to have you on here. This was very cool. Exonuclear is something that I have heavily promoted on this channel. I love the work that you and the other rate members did. I highly respect the what the members of the Rate Project. Dr. John Baumgartner, I've hit him on a couple times. He actually is a professor at the same school I go to, college I go to, Liberty University. So
Well,
that's awesome.
again,
But all right,
thanks for this opportunity to talk about these issues and make the presentation and help inform people.
right, awesome. And I know that I have my share of critics on here. That's unfortunate, but it's they don't want to let it go. So
Of course not, because ultimately it's a spiritual issue. They don't want to admit that there is a creator.
right. All right. Thanks again, and I'm
Thank
going to
you.
go ahead and close this off. And God bless.
Thanks, Brian. Take care.
You too.
Bye for now.